Hey, so this is a walkthrough of the paper one from Edexcel GCSE Foundation, November 2018. Paper one means that it's a non-calculator paper, and so we'll get cracking. Now, in this paper, I think there are 28 questions, okay? Remember, you need to make sure you're writing all your working out. You should probably consider using the links that will be below this video in the description so that you can work along with the video. So you might want to pause and then watch a question, and pause and watch a question, and try things out as you're going along. So let's get cracking. So write the following numbers in order of size, starting with the smallest number. Well, they're all 0 point. Okay, so the units aren't going to make a difference. Now let's look at the first number after the decimal place. This one starts with the 0, and so this one will definitely be smallest. So the first number after the decimal place is smallest in this number here, so we'll put 0.02. I like to circle them rather than scribbling them out or crossing them out, because that way you'll still be able to see them if you make a mistake. Okay, first number after the decimal place is a 4, a 3, a 1 and a 2. So this one is next smallest, 0.152. Next, first number after the decimal place is a 2 here, so that's 0.2. First number after the decimal place is a 3, so 0.37 and 0.4. Starting with the smallest number is what I've done. Make sure that you've always looked and seen whether it says starting with the smallest or starting with the biggest. Okay, moving on. Write 0.6 as a percentage. Now, percentage means that you want things to be out of 100. Per 100. Okay, so what's 0.6? Well, 0.6, it's in the tenths. So we've got units, tenths, which means that we have 6 tenths currently. But I want it to be over 100, so that it's per cent, so it's per 100. So I'm going to multiply the denominator by 10, because 10 times 10 is 100, and I'll multiply the numerator by 10. 6 times 10 is 60. So it's actually 60 per 100, which is 60 per cent. Okay, not too bad. Try to get things to be over 100 to do percentages. It makes things really easy. Next, from the list, write down a factor of 10. Now, factors of numbers are fewer than the original number. F is for factors, F is for fewer, so it's got to be smaller than 10. M is for multiples, M is for more, so often it'll be more than. So 20 is a trick, because that's actually a multiple of 10. A factor of 10, well, does 3 go into it? No. Does 7 go into it? No, but 5 does. 5 is a factor of 10. Write 7,829 correct to the nearest 1,000. Now, is it closer to 7,000 or 8,000? Take a look at it. If you had £7,829, you're closer to that, aren't you? Definitely. Look at the 8. The 8 will make the 7 round up. You should see, pretty obviously, that we've got 8,000. Okay, moving on. 3 multiplied by 5 plus 7. Now this, you might call it BIDMAS or you might call it BODMAS, but we've got to do, I'm going to go with BODMAS. There's no brackets, there's no powers, no order, no operations, you might call it. There's no division, there is multiplication, so we're going to do that bit first. 3 5s are 15 with a plus 7 on the end. Now 15 plus 7 is 22. So there are 22 is your answer there. 2 cubed. That means that you've got 2 times 2 times 2. Okay, imagine you had a cube which was of sides 2 by 2 by 2. The volume of that would be 2 times 2 times 2. So 2 cubed is going to equal 2 times 2 times 2. Well, 2 times 2 is 4, multiplied by another 2 is 8. Put brackets in this to make it correct. So, if we try putting in brackets in certain places, don't think that it's something that you need to watch out for and you can only put brackets in just once. Do a couple under here and then put them in as your final answer. Don't try to put your brackets straight onto this question here, because that's where it's expecting to see your answer. Okay, so you might try something. You might do, well, 7 times 2 in brackets plus 3. Well, 7 times 2 would go first anyway, and 14 plus 3 is 17, so that doesn't work. Okay, what about if we did 7 times by 2 plus 3. Well, 2 plus 3 is 5. Brackets go first, don't they? 7 times 5 is 35. So it's that one. So that is where the brackets go. Okay? In this sort of question, though, don't spoil the one you're supposed to write it on. Try it out in some working out space and then put your brackets on at the end. Okay, moving on. Sue has 2 cats and each cat equals a quarter of a tin of cat food each day. She buys 8 tins of cat food. Does she have enough to feed her 2 cats for 14 days? So, how much would she give out each day? Well, each day she has 2 cats, each eating a quarter of a tin of cat food. Okay, so there's my tin of cat food. There's one of the cats and there's the other one of the cats. And so each day we use a half tin of cat food. Okay, now for 14 days we're going to have 14 times where she'll be using half a tin of cat food. Now 14 lots of a half, you can think of that in lots of different ways, but 14 lots of a half is 14 times 1, which is 14, over 2, which is 7. That's one way of doing it. 14 times a half, you could think of it as being half of 14. If you wanted to, that's absolutely fine, and you'll get 7. So this is how many tins she needed to buy. She bought 8. Does she have enough? Yes. 8 is more than 7. So she has enough. Easy peasy. Okay, moving on. There are only apple trees, cherry trees, pear trees and plum trees in an orchard. The pictogram shows information about the numbers of apple trees, cherry trees, pear trees in the orchard. It's also got a space for us to put some stuff about plum trees. Now there's a total of 30 trees in the orchard. Now this box represents 4 trees, which means that a half box must represent 2, and means that a little chunk of a box must represent 1, and also kind of a 3/4 chunk where it's got a half and a little 1, that would be 3 trees. So here's 4 and 4 and 4 and 4, and that's 1, and there's 4, and there's 2 trees there. So we have 4 plus 4 plus 4, which is 12 apple trees, 5 cherry trees, and 6 pear trees. What's 12 plus 5 plus 6? Well, 12 plus 5 is 17, and 17 plus 6 is 23. So we have 23 trees. There are supposed to be 30 trees in the orchard, which means that if we do 30 take away 23, there must have been 7 plum trees. So we need to complete the pictogram. There'll be 1 full box, that's 4. I need another 3. It's going to have to be one of these annoying looking drawings. Which looks like that. And you're allowed to put the numbers in there if it helps you along. It's a nice question to pick up 3 marks on. Next, write down the coordinates of point A. Now, X on the deck, Y in the sky, along the corridor, up or down the stairs. Well, the first number that we go to is -2 and then down to -1. Make sure you get those in the right order. -2, -1, along the corridor, up or down the stairs. On the grid, mark with a cross the point 2, 3. So along the corridor to 2, up the stairs to 3, that's where it'll be. It says label this point B. There we go. Okay. On the grid, draw the line with the equation x equals -4. Now if this is the x-axis, you can see it there, there's a little x. -4 would be here. Whenever you have an x equals graph, okay, you'll have one that goes vertically, like that, okay. Obviously I should be putting on full lines, but it wouldn't be clear if I did it that way. And y equals graphs will go through the y-axis, okay. When you've got both x and y, you'll get slanted things, but x equals graphs will be vertical. And in this case, it will go through -4. Obviously I should be using a ruler, but I don't have that facility. Okay, moving on. If g equals 9 and h equals 4, work out the value of 2 g's plus 3 h's. That will be 2 g's plus 3 h's. Well, what's a g? G is 9. And 3 h's, 3 lots of 4. I like to put these things in brackets because when you're using a calculator paper, it means that you're not going to make a mistake with your negatives. 2 multiplied by 9. Putting things in brackets is just another way of writing a multiplication. 2 times 9 is 18, and 3 times 4 is 12. Add those up to get 30. Next, write down 2 prime numbers, so we'll come back to that in just a second, that have a sum. A sum is add up, okay? 2 numbers that add to make 32. So we need to list some prime numbers. We don't know what they are just yet. Now 1's not a prime, be really careful with that. But 2 is a prime, 3 is a prime, 4 is not a prime, and that is because 2 goes into it. 5 is a prime, 6 is not a prime, and that is because 2 and 3 go into it. 7 is a prime, 8's not because 2 goes into it, 9's not because 3 goes into it, 10's not because 2 goes into it, 11, 13, 17, 19, 23. There's lots and lots and lots. Now we need 2 that are going to add up to make 32. And there's probably plenty of them. For me though, the ones that immediately spring out are these 2, 13 and 19. They are 2 numbers that are both prime that add up to make 32. Obviously you could have got a different answer. I'm sure there are other ones. Next, here are some fractions. Which of the fractions is not equivalent to 3/4? Now, the trick with these is dead simple. Just simplify the fraction. Name a number that goes into 9 and 12. 3, isn't it? So divide them both by 3. So we'll get 3/4. Name a number that goes into 6 and 8. It's 2. So divide them both by 2. You get 3/4. Name a number that goes into 18 and 24. The biggest number that goes into those is actually 6. So we're going to divide them each by 6. Some people might say 2 and they'll get 9 over 12, but that still can be simplified. You see, we've seen that one before. So 18 divided by 6 is 3, 24 divided by 6 is 4, so that one's 3/4 as well. 10 over 16 is 5 over 8 when simplified, and 15 over 20 is 3 over 4. So which one is not equivalent? Not equivalent means it's which one is different to 3/4. It's that one there. So which one is different? It's 10 over 16. Work out 1/12 plus 5/6. Well, 1/12 is just 1/12. But if we want to get common denominators, I could multiply the numerator and the denominator of this fraction by 2. And so I'll get something over 12, which comes out as 10 over 12. 5/6 is exactly the same as 10/12. Okay? I have 1/12 plus 10/12, which would be 11/12, not 11/24. Remember, you only add up the numerator. I have 1/12 plus 10/12. How many 12s do I have? It's 11/12. At no point have I had any 24ths. So we get 11 over 12. Okay, moving on. Tom uses his lorry to deliver bricks. You can use this graph to find the delivery cost for different distances. For each delivery, there's a fixed charge plus a charge for the distance. Now, a fixed charge, if you've ever thought of getting into a taxi and you get into the taxi and on the meter straight away, it might say £2.50 or something like that. That's what the taxi driver has got as a fixed charge. It's something that he charges before he even turns up. You could almost think of it being the charge for him to kind of come and pick you up if you wanted to. Now, the fixed charge in this case is what happens when the distance is equal to 0. But when the distance is equal to 0, he's travelled 0 miles, I'm already paying £10 to Tom for the use of his lorry. So the fixed charge is £10. Tom makes 2 deliveries of bricks. The distance of one delivery is 20 miles more than the distance of the other delivery. Okay, work out the difference between the 2 delivery costs. Now I'm just going to make up some deliveries. So I'm going to have delivery 1 was going to be 10 miles. And delivery 2 is going to be 30 miles. Okay, now I've chosen 30 miles because it's 20 miles more than 10. 10 plus 20 is 30. So if we go 10 miles, how much does that one cost? Well, it's here. Now if this is 20 and this is 40, then this is 30. So smack bang in the middle of them will be 25. So 10 miles cost me £25 for Tom to turn up. And for 30 miles, we've gone from 30, obviously I should be using a ruler, okay, and we've got, this is 40 and this is 60, there's 50, so this must be 55. Well, what's the difference? 55 take away 25 is equal to 30. So the difference between the two delivery costs will be £30, and that will be the same whatever the deliveries were. I just made up 10 and 30 because I thought they looked easy. Okay, moving on. Asmal, Ryan and Kim each played a game. Asmal's score was 4 times Ryan's score. Kim's score was half of Asmal's score. Write down the ratio of Asmal's score to Ryan's score to Kim's score. So, first off, Asmal's score was 4 times Ryan's score. Okay, so we're going to say that Ryan's score was R, which means that Asmal's score was 4 times Ryan, 4R. So if Ryan got 5, Asmal got 4 times 5 is 20. Kim's score was half of Asmal's score. But what's half of 4R's? Well, that would be 2R's, wouldn't it? Now what we wanted was the ratio of Asmal to Ryan to Kim. So A to R to K. Now Asmal is 4R, Ryan is 1R, and Kim is 2R. Okay, that's still 1R that we don't always write down, but it's useful in this case. Now, given that as a ratio, that's almost done, but actually we don't need these R's anymore. 4 to 1 to 2. And there we go, 4 to 1 to 2. Moving on. The diagram shows a quadrilateral A, B, C, D with each of its sides extended. A to B is equal to A to D, which is shown by these little lines here. Show that A, B, C, D is a kite. Now to show that something is a kite, we need to prove that it's got 2 angles that are the same and opposite to each other. Okay, we need to prove that these are equal. And we also need to prove that those 2 sides are the same length, and also that these 2 sides are the same length. Okay, but it's perfectly fine for us to prove these. Okay, we can prove these and also prove that these 2 are different if we wanted to. Okay, so to prove for a kite, first I'm going to try to find out this angle here. Well, when you're doing these things, if you want to give a reason, it's easier if you just do it around the shape and you draw an arrow to it. So we're going to do 180 degrees on a line, take away 75 degrees, which is going to be 105 degrees, and that's because there are 180 degrees on a straight line. Okay. Next here, up here, that is going to equal 50 degrees, and because these are opposite angles, okay, opposite angles are equal. Now we need to find out this thing here. Now this shape, ABCD, is a quadrilateral, meaning that the sum of the angles is 360 degrees in total. Now if I did 360 degrees, take away the angles that I have, so take away 100, take away 105, and take away 50, I'll get this angle here. So 360 take away 100 is 260. Take away 105, take away 50. Take away 100 is 160. Take away another 5 is going to be 155. Take away 50 is going to equal 105. There is a much easier way of doing that. If you just add these 3 things together and then take it away from 360, you'll get an answer much quicker. Okay, there's 105 degrees. Okay, so these 2 angles are equal. and opposite to each other. These two angles are not equal. And are opposite to each other. Now, that is one way of proving that you have a kite. There are other ways, but I like that way. I think it's nice and easy, and you can use angles pretty heavily for it, and it's got pretty easy statements. Okay, there are probably other ways to do that question, but that's the way I would have gone about it. All right, moving on. Shahid is going to use these instructions to make a fizzy drink. So we've got 5 parts orange juice with 2 parts lemonade. So Shahid is going to have 2, 3, 4, 5 parts orange juice with 2 parts lemonade. All right, fair enough. Shahid thinks he has 300 millilitres of orange juice and 200 millilitres of lemonade. If Shahid is correct, what's the greatest amount of fizzy drink that he can make? So first we're going to consider what happens if he's got 300 ml of orange juice. Okay, so we've got 300 ml of orange juice. Well, if this is 300 ml here, then this would be 1, 2, 3, 4, 5, 300 broken into 5 chunks, which is 60s. So those are 60s. Which means that these are also 60s, which means that we've got 120 millilitres of lemonade. Now that works, that's good news, okay? We've got enough lemonade and we've got enough orange juice. Just to be sure, some of you will have worked out that he can't use all of his lemonade, there's no way to do it already. But just to be sure, if I wanted to, if I had 200 ml of lemonade, then this would be 100. These would all be 100s. But there are 5 of them, which would mean that if I used all 200 millilitres of lemonade, I would need 500 millilitres of orange juice, which I don't have. So it's this one here that's the recipe. He'll use 300 millilitres of orange juice and 120 millilitres of lemonade, leaving 80 millilitres left over. So what's the greatest amount of fizzy drink? It's these 2 things added up, because he's mixing together orange juice and lemonade. Sounds horrible. We've got 300 plus 120, which is going to be 420 ml. Okay, Shahid does have 300 millilitres of orange juice. Okay, fair enough, he's just gone and checked. But he's only got 160 millilitres of lemonade. Now, was he going to use 160 millilitres of lemonade? Well, no, we said that he was going to use 120 millilitres of lemonade. So does that affect it? No. He was only going to use 120 ml of lemonade. So he still has enough to make his absolutely horrible sounding drink. Alright, next up. Here are 2 rectangles. Jim says the rectangles are similar because 8 plus 4 equals 12, that's true, and 6 plus 4 equals 10, that's true, but Jim's wrong. Okay, Jim's definitely wrong. That's not how similar shapes work. Here are 2 similar shapes. If I knew that, say, this was 3 and this was 2, and this was, say, 6, then this would have to be 4. I can double the sides. Okay, it's all about multiplication to figure out whether you've got similar shapes or not. Okay, now is it true also that 2/3 is equal to 4/6? 2/3 is equal to 4/6. Could I put my numbers like that? Well, yeah, I could. You see, I could divide that by 2 and divide that by 2. So 2/3 does equal, this would cancel down to 2/3. And so my shapes up here, they're similar. It's a good way of doing it. Now let's see if Jim's right. Does 6 over 8 equal 10 over 12? Well, let's see. 6 over 8 is 3/4 by dividing each of the numbers by 2. 10 over 12 is 5/6 by dividing each of the numbers by 2. Now neither of these are going to simplify any further. Does 3/4 equal 5/6? No, it doesn't. Okay, so no. Here's wrong. That working up there is enough to show it. 6/8 does not equal 10/12. That's a nice way of writing does not equal. It cuts out a bit of your writing. Okay, as 3/4 does not equal 5/6. There we go. Remember, similar shapes are all about multiplication, not about adding. 80 people are asked if they like coffee. 48 of the people are women. The remainder are men. 61 of the 80 people like coffee. 8 of the men do not like coffee. Use the information to complete the frequency tree. Okay, so we've got 80 people asked if they like coffee. 48 of the people are women. Okay, so what's 80 take away 48? Well, 80 take away 40 is 40. Take away 8 is 32. You can use column subtraction for that as well. 0 take away 8 doesn't work. 10 take away 8 is 2. 7 take away 4 is 3. So there were 32 men. 61 of the 80 people like coffee. So I know that this, because this is for liking coffee and this is for liking coffee, that has to equal 61. Now, 8 of the men do not like coffee. Okay, 8 of the men do not like coffee. So we can't work with these because there's 2 things missing. We can't work with these because there's 2 things missing. We can find this out though using the fact that 32 must equal 8 plus something. Well, let's do 32 take away 8. 2 take away 8 doesn't work. 12 take away is 4. 2 is just 2. So there were actually 24 men who did like coffee. And there were 61 people who like coffee overall. So if we do 61 take away 24, 1 take away 4 doesn't work. 11 take away 4 is 7. 5 take away 2 is 3. And so there would be 37 women who did like coffee. Now there were 48 women. 37 liked coffee. 8 take away 7 is 1. 4 take away 3 is 1. And so in total there will be 11 women who did not like coffee. That's 3 marks. And really it's just a lot of subtraction. You need to be so comfortable with subtraction. Find one of the people who like coffee is chosen at random. So I could be picking any of these 61 people. What's the probability that they're a woman? So it's got to be these people here. Now, I'm telling you already that they like coffee, which means I couldn't be talking about this person, this 8 people, or this 11 people here. They are definitely going to like coffee. There's only 61 people I could possibly be talking about. So I get them all run around in the school hall. I've got 61 people in there, all pepped up on coffee, and I run them around. And then I'm going to pick out one of them at random, and I'm going to pick out a person that's a woman. Well, of those 61 people, 37 are women. So we've got 37 out of 61. Okay, moving on. Food Mart and Jan's store sell boxes of the same type of breakfast cereal. Each shop has a special offer. Which box of cereal is the better value for money? Now, value for money is value for money is how much do you get over the cost. Okay, so we've got 400 grams and then we've got 20% off the normal price of £5. So at Food Mart, well, we know that we're going to get 400 grams, but we get 20% off from £5. So we need to work out 20% off £5. Now, 10% of £5 is equal to 50p. 20% of £5 must be twice as much as that, which is £1. So if we're taking 20% off, 5 take away 1 is 4. So we're actually getting 400 grams for £4. Okay, which is 100 grams per £1. That might be handy to know in a minute. All right, Jan store. 400 grams plus 30% extra costs a £5. So at Jan store, we've got 400 grams plus 30% of 400 grams. Now we need to find out what's 30% of 400 grams. To do that, work out 10% of 400 grams. Well, that's 40 grams. So 30% must be triple that, which is 120 grams. Okay, so the total for Jan's store is 400 plus 120 grams, which is going to be 520 grams. So at Jan's store, you're getting 520 grams for £5. So how much do you get for £1? We can divide that by 5, and we can divide 520 by 5 as well. What's 500 divided by 5? Well, that's 100. What's 20 divided by 5? Well, that's 4. So actually we're getting 104 grams for £1. Of course, you could do 520 divided by 5 as well. 5 into 20 don't go, 2 don't go, 5 into 20 go 4 times, you get 104. So at Jan's store, you're getting 104 grams per pound, and at Food Mart, you're getting 100 grams per pound. So actually the better value is from Jan's store. All right, moving on. Rotate shape A 180 degrees around point 10. Now obviously this is going to be difficult because I can't show you anything to do with tracing paper, but 10 is 1 in and 0 up, like that. Now what you would normally do is you would take a piece of tracing paper like this, and you would normally draw all the way over the edge of the shape, put your pen on the little cross, and you would turn the tracing paper with your pen on the little cross, and so the tracing paper would turn all the way around 180 degrees. A good trick as well is that you can put an arrow that points upwards, and so after 180 degrees it should be pointing directly downwards. Okay, and when it does that, the shape will actually end up in this position here. Okay, it's not massively easy to visualize without using a tracing paper, but if you're in an exam and you want some tracing paper, you must ask for it. Okay, that's where it would be in the end. All right, moving on. Work out the value of 3 to the power of 7 multiplied by 3 to the power of negative 2 all over 3 to the power of 3. Now it would be very silly to do 3 times 3 times 3 times 3 times 3 times 3 times 3 to work out 3 to the power of 7. First, we're going to look at the numerator. We've got 3 to the power of 7 multiplied by 3 to the power of negative 2. When you've got the same base number and you're multiplying, you can add together the powers. So you're going to get 3 to the power of 7 plus minus 2. Now plus and minus 2 would be a minus, so you'll get 3 to the power of 5. 7 take away 2 is 5. Now that means that this question is 3 to the power of 5 divided by 3 to the power of 3. 3 to the power of 5 divided by 3 to the power of 3. Now, when you've got the same base number and you're doing division, you can subtract the powers. 5 take away 3 is 2. There's our answer, 3 squared, but that's not the value. The actual final answer, 3 squared, is 9. Okay? It's called index laws. Next, if v squared equals u squared plus 2as, and u equals 12, a equals negative 3, and s equals 18, we need to find a value for v. Now v squared must equal, well, u squared is 12 squared plus 2 lots of a, which is negative 3, lots of s, which is 18. Which means that v squared equals, well, what's 12 squared? 12 times 12. 12 times 12 is 144. 2 3s are 6, and we need to do 6 times 18. 6 8s are 48. 6 1s are 6, plus a 4 is 10. So we get 108. Now look, there's a negative there. If there were two negatives, you'd get a positive result, but there's a negative there, which means that we have to take away. Now, v squared will equal 144 take away 108. 4 take away 8 doesn't work, but 14 take away 8 does. It makes 6. 3 take away 0 is 3, pardon me. And 1 take away 1 is 0. So v squared actually equals 36. So how are we going to find out v? Well, we can square root. So we can square root, and we can square root, and you'll end up with the square root of 36, which is 6. V equals 6. Make s the subject of this thing. Now, v squared equals u squared plus 2as. Let's talk about what's happening with s at the moment. S is being multiplied by 2a, and then we're adding on u squared, and that makes v squared. At the moment, s is being multiplied by 2a, and then we add on u squared. It doesn't matter that they're not in the order where you've got plus u squared at the end. You're still adding on u squared. So, let's try to make s the subject of this. Start with v squared and work backwards. You would take away u squared, and you would divide by 2a, and you would get your s. So, v squared, take away u squared, divide all of that by 2a. Best way to divide all of that by 2a is to put it all over 2a. And then that will be s. Okay, there are lots and lots and lots of different ways to go about this question. But that's quite a nice way to do it, to undo a function machine. Let's move on. A bonus of £2,100 is shared by 10 people who work for a company. Now 40% of the bonus is going equally between 3 managers. I bet they decided that. The rest of the bonus is shared equally between 7 salesmen. If one of the salesmen said, if the bonus is shared equally between 10 people, I would get 25% more money. Now I think he will get more money, but I don't know whether it will be 25%. So let's find out if he's correct. So there are 2 things that are happening here. You've got one, which is 40% to the managers, and the rest to sales. Okay, well, if 40% goes to the managers, then 60% goes to sales. And you've got this one, which is all equal. Okay, and we're going to have 2 different answers here, and we're going to compare them at the end. So 60% goes to sales. Well, what's 60% of 2,100? Well, 10% of 2,100 is 210. So 60%, because we divided by 10, didn't we? So 60% of 2,100 would be 210 multiplied by 6, because if we know 10%, we can multiply it by 6. Well, 210 multiplied by 6. 6 times 0 is 0, 6 times 1 is 6, and 6 times 2 is 12. We get £1,260. That is for all 7 salesmen to share. So how much does one salesman get? Well, he starts off with getting a part of 1,260. He gets 1/7 of it, so we're going to divide by 7. 7s into 1 don't go. 7s into 12 go once, remainder 5. 7s into 56 go 8 times, and 7s into 0 go 0 times. And so each salesperson, they get £180 each. Now if it was equal shares, there's £2,100 just divided amongst 10 people, which is £210. Now he definitely gets more. He gets £30 more, doesn't he? But is that 25%? So what he's saying is he'd get 25% more than this if we equally shared it out. So what's 25% of 180? Well, 100% of 180 is 180. 50% would be half of that, which is 90. And 25% would be half of that, which is 45. So if he was to get 25% more money, he'd get £45 more. But he doesn't, he only gets £30 more. So he gets £30 more. This is not as much as £45 which is 25% more. So no, he's not correct. He would get more money, but it wouldn't be 25% more money. Okay, moving on. It would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes would it take to fill the pool if only 3 of the taps are used? So 120 minutes is what it takes for 5 taps. What do you reckon it would take to do it all with 1 tap? Well, surely it would take 5 times longer. It would take 5 times longer to do it with 1 tap. Okay, so I'm going to times by 5. What's 120 multiplied by 5? Well, 5 times 0 is 0. 5 times 2 is 10. Carry that. 5 times 1 is 5, plus the 1 makes 6. So if there was just 1 tap, it would take that 1 tap 600 minutes. But actually we're saying that there's going to be 3 taps. Really often with this type of question, find out the value of 1 and then work from there. So with 3 taps, it's going to be 1/3 of the time of that. So we're going to divide by 3. So it's 200 minutes it should take for 3 taps. Now, one assumption that I made is that all the taps work at the same speed. It could be that this has got like a super powerful tap in it. It's got 4 normal ones and then 1 super power tap. And this thing does or doesn't have that super power tap, and that will affect the speed that it takes. So one assumption is that all taps work at the same rate. There we go. Okay, nice and easy. Moving on. A plane travels at 213 miles per hour. Work out an estimate for the number of seconds it takes for the plane to travel 1 mile. Now, estimate is what we're going to pay attention to. If it's travelling 213 miles per hour, you should know that when you're estimating, you round to one significant figure. Is this closer to 200 or to 300? Seems pretty obvious that that's 200. So the plane travels 200 miles in 1 hour. But I really want to talk about seconds as much as I possibly can. So how many seconds are in an hour? Well, there are 60 seconds in a minute, and there are 60 minutes in an hour. Well, 6 times 6, 36. 2 zeros on the end. So there are actually 3,600 seconds in an hour. You can count them if you want. 3,600 seconds in an hour. So 200 miles still takes 1 hour, but it also takes 3,600 seconds. They're exactly the same value. So we want to know how long is it going to take to do 1 mile. So 1 mile. Now we can divide by 200 here. We can cut this journey up into 200 tiny little chunks of each being a mile. And if I do the same over here, if I divide by 200, I have 3,600 divided by 200. Now I can cancel off this 0 and this 0, cancel off this 0 and this 0, and I'm left with 36 over 2, which is 18. 1 mile is 18 seconds. So how long does it take to travel 1 mile? 18 seconds. That was worth 3 marks, by the way. For some reason I haven't put the little dotted line on there. There's 1 here, and there's 4 in total, so that must be worth 3. Is your answer to part A an underestimate or an overestimate? Well, in real life, so not in the world of estimates, the plane is actually faster. So will it take more or less time? Well, if it's faster, surely it'll take less time. Usain Bolt's faster than me, and so if we're doing 100 metres, he's going to take much less time. So in real life, the plane is faster, so will take less time. It'll take less than 18 seconds. So I have overestimated. My estimate is over the actual value. The actual value would be 17 seconds or something like that. I've gone over it, but it's a good estimate. I won't be miles off. All right, moving on. Solve the simultaneous equations. Now these are really tricky, and foundation means right up towards the end, obviously, and we're getting quite close towards the end of the paper. Now to do these, you need to equate some of the coefficients. Now, The coefficient to x here is 5, the coefficient to x here is 1, the coefficient to y here is 1, and the coefficient to y here is negative 3. I need to make it so either the x's have got the same number in front of them or the y's have got the same number in front of them. Now most people tend to just go for the x's no matter what. Now I'm going to try to make them so they've both got 5x at the start, because 5 goes into 5 and 1 goes into 5. Wouldn't make any sense for me to choose 6, for example. If I tried to multiply this to make it 6, I'd be multiplying by 1.2, multiplying by this to make 6. It'd be really difficult. So we try to get a number that matches for the x's. Now, in this case, if this was 5x, well then, those other bits are done. Okay. If this was 5x, it would mean I've got 5 of that entire row. So I've got 5 times 1x, which is 5x. I've got 5 times negative 3, which is negative 15y. And 9 times 5 is 45. Now there's a good rule here, which is same signs, subtract. So here, look, they're both positive. What I'm going to do is I'm going to subtract this row. I'm going to subtract this row from this row. What's 5x take away 5x? What would 5x take away 5x's be? Well, if I had 5x's and I gave them all away, I'd have nothing left. Next, I've got 1y take away minus 15y. Two minuses, they make a plus, don't they? So I'll have 1y plus 15y. That's going to be 16y. And I've got 21 take away 45. If you ever struggle with that, just do 45 take away 21 and make your answer negative. Well, 45 take away 21 is 24. So 21 take away 45 will be negative 24. Okay, so that equals negative 24. So now we know that 0, well, that's fine, we don't really need that, but 16y equals negative 24. So 16y equals negative 24. That means that y equals negative 24 over 16. Now each of those numbers is a multiple of 8, so I can divide through by 8, and I can say that y is equal to negative 3 over 2, which is the same as negative 1.5 if you wanted to call it that. Okay, it does make this question a little bit easier if you call it negative 1.5. Okay, if you're not sure how to do that, how many 2's go into 3? It's 1 and 1/2, for example, and you could then say that that's 0.5. All right, now we need to find out x. Now, if 5x plus a y equals 21, 5x plus 1y, whatever y is there, equals 21, and y equals negative 1.5, we should be able to solve this. Well, I'm going to add 1.5 onto each side. And I'm going to get 5x minus 1.5 plus 1.5, well, they just cancel each other out. And 21 plus 1.5 is 22.5. And x, we can divide through by 5, is going to equal 22.5 divided by 5. Now, what's 22.5 divided by 5? Well, 5's into 2 don't go. 5's into 20 go 4 times. Remainder 2. 5's into 25 go 5 times. And so x equals 4.5. Okay? Job done. Really difficult one. Really, really difficult. But that's basically as difficult as they tend to get, really. So if once you get into the pattern, you sort of see what you're doing really often anyway. They're generally quite similar to each other, but they're not easy. Okay, speaking of not easy, this one's not easy either. The diagram shows a square ABCD. Now, if that's 20 and this is a square, this is also 20. Fine. It also shows a semicircle, which is this bit in here, that's a semicircle. And an arc of a circle, which is that bit there. AB is the diameter of the semicircle, so the semicircle would carry on around like that. Okay, it wouldn't go really, really, really massive, but AB is the diameter of it. AC is an arc of a circle with the centre B. So this would be B. This circle in this case would be massive, really, really, really big. Okay. And what it says is show that the area of the shaded region divided by the area of the square is going to equal pi over 8. So we're going to need to work out the area of the shaded region. Now the area of the shaded region, to me, I look at it and I see that quarter of a circle, the one with A, B and C there. I could shade all of that in. And then if I took away that chunk there, A, B, what would I be left with if I took away that bit there? Surely I'd be left with just that bit there that I've coloured in more darkly, which is the shaded in section. So this here is 1/4 of a circle. Now remember, pi r squared sounds like area to me. So this is 1/4 of a big full circle, which is pi times pi. What would the radius be of this circle? If we knew the whole entire circle, we would see that the radius is just this line here, which is 20. So we have 1/4, lots of pi times 20 squared, minus, it's 1/4 by the way, because you've got a quarter circle. Semicircle is 1/2 of a circle, and the circle in this case would be pi times pi. What would the radius of this circle be? Well, the radius would be that bit there, which is half of 20, which is 10 squared. Okay, so let's work these bits out, and once we work this bit out, we'll find out an expression for the area of the shaded section. So we've got 1/4, lots of pi times by 20 squared. Now 20 times 20, which is 2 times 2 is 4, and 2 zeros, 400. Minus 1/2 of pi times 10 times 10 is 100. Now we've got 1/4 of 400 pi minus 1/2 of 100 pi. What's 1/4 of 400 pi? If I had 400 pi and I cut it up into 4 chunks, well, surely that would be 100 pi. Okay? And if I've got 1/2 of 100 pi, if I've got 100 pies and I cut it into half, surely I would have left over just 50 pi. And 100 pi take away 50 pi would leave me with just 50 pi. Okay? That is an expression for the area of that shaded section. Now we said the area of the shaded region, which we now know is 50 pi, over the area of the square. Now the square is equal to 20 times 20. 20 times 20, or 20 squared if you wanted to call it that, which is 400. We already did that some once. So that would be 400. So actually we know the area of the shaded region is 50 pi over the area of the square, which is 400. Now these have a common factor, which is 50. So we can divide by 50. It's 50 divided by 50, it's 1, and pi is just pi. 400 divided by 50. Well, 400 broken up into 50s, you've got 50, 100, 150, 200, 250, 300, 350, 400. And there will be 8 of them in total. And 1 pi over 8 is exactly the same as pi over 8, which is what we were expecting to get. All right. Second to last question. There's question 27 and question 28, and then we're done. Amina has 2 bags. In the first bag, there are 3 red balls and 7 green balls. In the second bag, there are 5 red balls and 4 green balls. Amina takes at random a ball from the first bag, and then she takes a random ball from the second bag. Complete the probability tree diagram. Well, in the first bag, there are 10 balls and 3 of them are red. 3 out of 10 balls are red. So how many are green? Well, 7 out of 10. Would you believe it? Nice and easy. If there are 5 red balls in the second bag and there are 4 green balls, well, there's going to be 4 greens out of 9 balls in total. Now these, unless you've got a question where, say, somebody eats a sandwich and doesn't put it back, you've got a non-replacement question, which are a bit more rare at foundation. These should be the same as these. Okay, so we get 5/9 and 4/9. Okay, this is a non-replacement this is a replacement question, so the probabilities sort of don't change really as you're going like vertically. And one way that they can be shown is to have like 2 different bags, so one bag doesn't affect the other. So in this case, these 2 are the same as these 2. It's nice and easy. Now that there, would you believe it, is worth 2 marks on the second to last question, which is lovely, isn't it? It's really nice because by this point it'd be quite difficult to be picking up marks. Now work out the probability that Amina takes 2 red balls. So she's going to take a red followed by a red. Okay, so we're looking at this section here. Now to get that, we're going to do the 3/10 multiplied by 5/9, not added. Okay, sometimes people accidentally add. The rule of thumb with tree diagrams is that you multiply that way, and sometimes you might have a couple of these that work for your answer, which is to add that way. But you always multiply. Okay, across looks like a cross, multiply across. Same goes with fractions. If you're multiplying fractions, multiply across. 3 5s are 15, 10 9s are 90. Doesn't ask for simplest form, so I can give 15 over 90. It's absolutely fine. You can simplify it if you want to, okay, but I don't need to, so I'm not going to. Okay, I could call it 1/6 if I really, really wanted to, but with probability, you really often don't need to. Okay, 15 over 90. And on to the last question. The size of each interior angle of a regular polygon is 11 times the size of each of the exterior angles. Work out how many sides the polygon has. Now, if we imagine that this is the inside of my shape, and this is the outside, so obviously the shape would carry on all the way around here. An exterior angle, you carry on one of your inside lines. It's not, say for instance, that's interior and this is an exterior angle. It's not like that. If you had a triangle, for example, you just carry on the lines. Obviously, you try to do them straight. Those would be exterior angles. Okay. Now, the interior angle is 11 times the size of each exterior angle. Now, my exterior angle, I'm going to call it x, which means that my interior angle would be 11x. It's 11 times. Now these two form a straight line, so 11x plus 1x must equal 180. They form a straight line. There's 180 degrees on a straight line. So 12x equals 180. That means that x equals 180 divided by 12. So let's find out what that is. 180 divided by 12. Does 12 go into 1? No. But does 12 go into 18? Yes. Once, remainder 6. Does 12 go into 60? Yes. 5 times. And so we've found that x is equal to 15. Okay? X is equal to 15. Now, we need to work out how many sides the polygon has. This is a regular polygon, which means that all of the exterior angles would be exactly the same. Now, if we had this equilateral triangle here, for example, this plus this plus this would be exactly the same, but these exterior angles will always add up to 360 degrees. So you would have, they add up to 360. If you put them together, imagine you put them together, you would have that one, and then that one, and then that one. You'd have all three of them like that. They make 360. And it's divided by 3 angles, and so each of those would be 120 degrees. Okay, a similar thing happens to squares, pentagons, whichever ones else you want. In this case, though, we know that this is equal to 15. There are going to be a bunch of 15-degree angles all the way around this shape. All of them will be exactly the same size because they're all regular it's all a regular polygon. So how many of them make up the 360? 360 divided by what equals 15? 350 divided by what? How many times do I have 15 involved in it? Well, I can actually just do 360 divided by 15 equals what? So 360 divided by 15. How many 15s go into 3? None. How many 15s go into 36? 2, remainder 6. How many 15s go into 60? 4. And what that means is that you've got 24 of those exterior angles. Exterior angles. There are 24 of them. They're all exactly the same. Now, there were 3 exterior angles in a triangle. There would be 4 exterior angles in a quadrilateral. There will be 5 exterior angles in a 5-sided shape. There are 24 exterior angles in a 24-sided shape. And so it would have 24 sides. Okay? Hopefully that was useful. That's a whole entire foundation paper done. In the description to this video, you'll have a link to these worked solutions and also to the actual paper. It might be a good idea to go through the paper try it out and see what you can remember, and then maybe come back to the video and rewatch it or use the work solutions to help you along. Okay? Try to think about which ways this is going to be useful for you, but it's not great to just watch the video and hope for the best. All right, thanks very much.